The forgotten stain removal secret isn't a $15 spray bottle from the cleaning aisle or a $600 professional bathtub reglaze. It's oxalic acid powder from the wood restoration aisle at any hardware store. Mix 2 tablespoons of powder into 1 quart of warm water, apply it to rust rings and hard water stains, walk away for 20 minutes, and rinse. No scrubbing. The acid performs a double displacement reaction with the iron oxide, converting it to iron oxalate, a completely water-soluble compound that rinses away. $1 per application permanently eliminates stains that commercial sprays can only manage temporarily. This is the Rogue Archivist. The global household cleaning market is a $200 billion empire built on repeat purchases. The average family spends $700 to $1,800 per decade on bathroom cleaners that manage stains but never eliminate them. When you finally give up, you pay a professional $300 to $600 to reglaze your bathtub. You just bought permanent molecular stain removal for $1 using chemistry that was perfected in 1882. $1 versus $1,800 over 10 years. The math is so absurd that the moment you see it, you'll understand why the cleaning industry uses shelf placement economics to bury oxalic acid powder in the paint aisle while spending billions advertising surfactant sprays that are designed to fail. But just knowing the chemical name is only 10% of the secret. Today, I'm going to show you the exact double displacement reaction that makes oxalic acid superior to any commercial bathroom cleaner. I'm going to show you how a 1776 Swedish chemist isolated this compound from sorrel leaves, how an 1882 American chemist created the original Barkeeper's friend by cooking rhubarb in a grease-stained pot, and how the modern cleaning industry buried this permanent solution to protect their recurring revenue model. And I'm going to show you the critical dilution ratio and safety protocols that determine whether this method eliminates stains permanently or causes surface damage. By the end of this investigation, you will have the blueprint to restore any rust-stained or mineral-stained surface and bypass the cleaning product Cartel forever. Let's begin. The science behind stain formation and removal begins with understanding what these stains actually are. Rust stains are iron oxide. When iron-containing water sits on porcelain, the iron oxidizes and bonds to the surface at the molecular level. Hard water stains are calcium carbonate and magnesium carbonate. When hard water evaporates, these minerals are left behind and crystallize on the surface. Both types of stains form chemical bonds with the porcelain or tile. They are not dirt sitting on top. They are minerals chemically attached to the surface. This is why scrubbing doesn't work. You are trying to physically remove something that is chemically bonded. Commercial bathroom cleaners use surfactants. Surfactants are soap molecules that reduce surface tension and allow water to lift away dirt and oils. They work excellently on organic grime like soap scum and body oils, but they cannot break mineral bonds. A surfactant can make rust look slightly better by removing the dirt around it, but it cannot remove the iron oxide itself. This is why you scrub for hours and the stain remains. The chemical doing the cleaning is incapable of solving the problem. The industry knows this. But surfactant-based cleaners are cheap to manufacture, easy to package, and create recurring purchases because they never permanently fix anything. This is the business model. Oxalic acid works through completely different chemistry. Oxalic acid is a dicarboxylic acid, meaning it has 2 carboxyl groups that can donate hydrogen ions. When oxalic acid contacts iron oxide, a double displacement reaction occurs. The acid donates hydrogen ions to the iron oxide. The iron releases from the surface and bonds with the oxalate ions from the acid, forming iron oxalate. Iron oxalate is water-soluble. It does not bond to porcelain. It rinses away completely. The rust stain is not scraped off. It is chemically disassembled and converted into a different compound that has no affinity for the surface. This is molecular-level cleaning, and it works on calcium and magnesium deposits through the same mechanism. The acid converts insoluble minerals into soluble compounds. The stains disappear. The historical development of this chemistry goes back to 1776, when Carl Wilhelm Scheele, a Swedish chemist working in a pharmacy, was investigating the chemical properties of plants. He boiled sorrel leaves, a common European plant, and isolated a sour-tasting compound. He named it oxalic acid, after the plant genus Oxalis. Scheele documented that this acid could dissolve mineral deposits and had bleaching properties. His work was published in chemical journals, and oxalic acid became a subject of scientific interest. By the early 1800s, chemists had identified oxalic acid in other plants including rhubarb, which contains high concentrations in its leaves. In 1882, George William Hoffman, an American chemist and entrepreneur, made a discovery that would commercialize oxalic acid for household use. Hoffman was cooking rhubarb in a pot that was blackened with grease and rust stains. After boiling the rhubarb, he noticed the pot was gleaming clean. The oxalic acid from the rhubarb had stripped away the stains without any scrubbing. Hoffman realized this chemistry could be marketed as a cleaning product. He began extracting and purifying oxalic acid from rhubarb and other sources, packaging it in brown paper bags, and selling it to tavern owners for polishing brass rails and fixtures. The product was highly effective, inexpensive, and required no scrubbing. Hoffman's formula became the basis for Barkeeper's Friend, which is still sold today as a cleaning powder containing oxalic acid. For decades, oxalic acid-based powders were standard household cleaners. Grandparents kept a tin under the sink. You mixed a small amount with water, applied it to stains, and rinsed. Bathtub stayed spotless. Brass stayed polished. The chemistry worked perfectly, and because it was so effective, one tin lasted for years. This was a problem for the emerging cleaning product industry. A product that solves problems permanently does not generate recurring revenue. In the mid-20th century, the household cleaning industry began shifting toward liquid surfactant-based cleaners. These products were marketed as modern, convenient, and safe. The messaging was powerful. Powders were old-fashioned. Liquids were advanced. Spray bottles were easy. And the products were designed for frequent repurchase. A bottle of surfactant cleaner might last a few weeks. Then you buy another and another. The revenue stream never stops. Meanwhile, oxalic acid powder remained available but was repositioned. Instead of being marketed as a bathroom cleaner, it was sold as a wood bleach and rust remover for restoration projects. It was moved from the cleaning aisle to the paint and wood finishing aisle. The packaging became plain and industrial. No bright colors, no advertising, no shelf presence. The product still worked exactly as it had in 1882, but consumers no longer knew it existed. The modern cleaning industry does not ban oxalic acid. They use shelf placement economics to hide it. Walk into any hardware store or supermarket. The cleaning aisle is 50 feet long, with hundreds of products in brightly colored bottles with massive advertising budgets. Oxalic acid powder is in a different aisle entirely, in a plain white tub, with no marketing. The average consumer never sees it. And the cleaning companies spend billions ensuring you never think to look for it. They advertise surfactant sprays on television. They sponsor influencers. They create brand loyalty, all for products that cannot chemically remove the stains they claim to clean. This is not incompetence. This is strategy. Here's what happens when you follow the industry's advice. You buy a $15 bottle of bathroom cleaner. You spray it on rust stains. You scrub. The stain lightens slightly. You repeat weekly. The stain never fully disappears. Eventually, after years of scrubbing and buying bottles, the porcelain becomes scratched from abrasive scrubbing and the stain is set even deeper. You give up and call a professional. They charge $600 to reglaze the bathtub. The reglazing lasts a few years before new stains form. The cycle repeats. Over a decade, you spend hundreds on cleaners and potentially thousands on reglazing, all because you were never told that $1 worth of oxalic acid could have prevented the entire problem. But if you had used oxalic acid from the beginning, none of this would happen. The rust stains would be chemically disassembled and rinsed away. No scrubbing, no damage, no recurring purchases. The bathtub would stay clean with minimal effort, and you would spend $1 per year instead of hundreds. This is the knowledge they buried. Now I'm going to give you the exact method. But first, critical safety warnings. Oxalic acid is a strong acid. It can irritate skin and eyes. You must wear rubber gloves and safety glasses. Work in a ventilated area. Do not inhale the powder. Keep it away from children and pets. And never mix oxalic acid with bleach or other cleaners. Acid plus bleach creates toxic chlorine gas. Use oxalic acid alone. These precautions are not optional. Product selection. Go to a hardware store, look in the paint aisle or wood restoration section. You want pure oxalic acid powder. Common brands include Savagran wood bleach, Barkeeper's Friend powder, or generic oxalic acid sold in plain containers. Read the label to confirm it is oxalic acid. A 1-pound container costs $5 to $10 and it will last for dozens of applications. Mixing ratio. For typical bathroom stains, mix 2 tablespoons of oxalic acid powder into 1 quart of warm water in a plastic bucket. Stir until dissolved. The solution will be clear. For extremely heavy stains, you can increase the concentration to 4 tablespoons per quart. For light stains, 1 tablespoon per quart may be sufficient. Start with the standard 2 tablespoon ratio and adjust if needed. Application method. Put on your gloves and safety glasses. Use a sponge or cloth to apply the oxalic acid solution to the stained surface. You can also pour the solution directly onto horizontal surfaces like bathtub bottoms. Make sure the stain is completely covered. Do not scrub. The acid does the work. Let the solution sit for 10 to 20 minutes. For heavy rust stains, you may need 30 minutes. The acid is breaking molecular bonds during this time. You will see the stain begin to lighten or change color as the iron oxide converts to iron oxalate. Rinsing. After the dwell time, rinse the surface thoroughly with water. Use a sponge or cloth to wipe away the dissolved stain. The stain should rinse away completely. If any residue remains, apply a second treatment. For extremely old or heavy stains, you may need 2 or 3 applications. But each application chemically removes a portion of the stain. Eventually, the surface will be completely clean. Post-treatment. Once the stain is removed, wash the surface with regular dish soap and water to neutralize any remaining acid. Dry the surface. The porcelain or a tile should look new. The molecular bonds holding the stain have been broken. The stain cannot return unless new iron-containing water sits on the surface and forms new rust. Common applications. Oxalic acid works on rust stains in bathtubs, sinks, and toilets. It removes hard water stains from glass shower doors and tile. It cleans calcium deposits from faucets and fixtures. It brightens grout. It removes rust from concrete driveways and sidewalks. It restores stained wood decks. It polishes brass and copper. The same chemistry works across all these materials because the stains are the same. Mineral deposits that bond to surfaces and are removed by double displacement reactions with acid. Limitations and cautions. Oxalic acid is safe for porcelain, ceramic tile, glass, concrete, and most metals. Do not use it on marble, granite, or other natural stone. The acid will etch the stone and cause permanent damage. Do not use it on aluminum. It can cause discoloration. Always test on a small, inconspicuous area first if you are uncertain about material compatibility, and never leave the acid on surfaces for extended periods beyond 30 minutes. It is powerful and can damage some finishes if overused. Environmental and health considerations. Oxalic acid is a naturally occurring compound found in many plants. It breaks down in the environment. It does not persist like some synthetic chemicals. However, it is toxic if ingested. Store it securely. And dispose of used solution properly by diluting with large amounts of water before pouring down the drain. Do not dump concentrated acid solution directly. This is a $1 investment that eliminates your dependency on the $200 billion cleaning product industry. No endless scrubbing. No recurring purchases of surfactant sprays that cannot break molecular bonds. No $600 professional reglazes. You have just reclaimed chemistry that was isolated in 1776 and commercialized in 1882, using knowledge that the modern cleaning industry systematically buried through shelf placement and advertising saturation. And once you understand that this is possible, you start to realize that many of the other systems you depend on are built on the same model. Temporary management replacing permanent solutions. Recurring purchases replacing one-time fixes. Marketing budgets replacing actual effectiveness. Your grandparents had spotless bathtubs with a single tin of powder under the sink. You shouldn't be funding a $200 billion industry that profits from your endless scrubbing. By bringing this 1882 chemistry back into your home, you bypass the entire cleaning aisle and restore your property permanently with your own two hands. The modern cleaning industry has convinced you that you are helpless without their brightly colored spray bottles and complex multi-step systems. That you cannot remove stains without scrubbing for hours. That maintaining a clean home requires continuous purchases of proprietary formulas. But the historical record and the chemistry prove otherwise. Swedish chemists in 1776 understood oxalic acid extraction. American entrepreneurs in 1882 commercialized it for tavern brass polishing. Your grandparents used it to keep bathtubs spotless for decades. They used knowledge that was documented in chemical journals and product packaging before the cleaning industry buried molecular stain removal and replaced it with surfactant management products. That knowledge was systematically hidden from you. And now you have it back. Use it. Restore your surfaces. Eliminate your stains. And remember